Hello and welcome. I'd like to take this opportunity to give you a brief review in regards to factoring polynomials. I'll cover factoring binomials, such as the difference of squares, trinomials, where we'll use the diamond method, and polynomials with four terms, where we will factor by grouping. Anytime you are factoring a polynomial, you will always follow these first two steps. Step 1. We will identify and factor out any GCF. Step 2. After we have done that, we will factor the remaining polynomial if it is possible. So down below, I have broken down the three different cases for you. The first is where there are four terms. In this case, we will simply factor by grouping. We will split our polynomial in half, take out the greatest common factor of the left, take out the greatest common factor of the right, and then the greatest common factor of the remaining entire polynomial. If there are only three terms, then you will use your diamond method if possible. Remember that in our diamond method, the goal is to rewrite the three terms as four terms so that we can factor by grouping. The last case is where there are only two terms. Here we will apply the difference of squares if possible. In our first example, I'll go ahead and factor by grouping. So down below, my very first step always, no matter what, is to look for a greatest common factor between all four terms. Between all four of these terms, I see that they are all divisible by 3, so I'm going to factor out a 3. My remaining polynomial is n to the third minus 2n squared plus 3n minus 6. Now looking at this remaining polynomial inside, I have four terms, so I may factor that polynomial by grouping. Factoring this polynomial, I will end up with two sets of parentheses. So down here, I'm going to go ahead and set up what my answer is going to look like. Those four terms inside the parentheses will break down into two new sets of parentheses. This 3 on the outside will simply remain on the outside. Setting up your answer with a 3 on the front helps you in two ways. First, you won't be confused by that 3 on the front as you proceed to factor from here. And second, you won't forget to bring that 3 down to the front of your answer when you are done. So now that I've brought that 3 down and set up my answer, I'm going to focus on this polynomial inside. N to the third minus 2n squared plus 3n minus 6. I will factor by grouping by splitting it into two parts. The greatest common factor on the left I see is only an n squared. Dividing n to the third by n squared, I'm left with just n. And dividing this negative 2n squared by n squared, I'm left with just a negative 2. On the right, I'm going to take out a positive 3. Remember, we always want that first coefficient to be positive. Since it's already positive, I'm just taking out a positive 3, leaving me with n, and dividing negative 6 by 3, I have a minus 2. Now from here, I see a greatest common factor of n minus 2, so I'm going to take those out to the front. I'll have an n minus 2 in the front, and the remaining binomial consists of the n squared and the plus 3. These are your two factors that you will fill in your answer with. Remember, you have that 3 as a coefficient on the front, and your two factors are n minus 2 and n squared plus 3. To the right, we are going to use our diamond method because there are only three terms. Now remember, as I said a moment ago, our goal is to rewrite these three terms as four terms so that we factor by grouping. Step 1, always, I'm going to look for any greatest common factor between all of the terms. Looking at all three of these terms, I see that they are all divisible by 2. So I'm going to factor out a 2, leaving me with positive 2m squared plus 9m minus 5. Now that remaining trinomial inside the parentheses, I am going to factor using my diamond method. I know that when I factor, that polynomial is going to end up factoring into two sets of parentheses. So I'm going to set up my answer down below. Now remember that 2 on the front, I'm just going to bring down and write as a coefficient of those two parentheses. Now I'm just going to focus on that polynomial inside and factor by grouping after I've rewritten it as 4 terms. So I have 2m squared plus 9m minus 5. Step 1, I need to write my diamond and multiply the leading coefficient of 2 by the constant term of negative 5. That number goes on the top of my diamond. On the bottom of my diamond, I write my middle coefficient, which is a positive 9. On the left and the right, I need two numbers that multiply to a negative 10 and add to a positive 9. Those two numbers are going to be positive 10 and negative 1. So what I am going to do from here is simply rewrite my 9 as 10m minus 1m. We're using those two numbers on the left and the right of your diamond to rewrite that middle term. The 2m squared still remains on the front, and the minus 5 still remains on the end. Now that I have 4 terms, I may factor by grouping. So I split this down the middle and look for the greatest common factor of the left, which would be 2m. Factoring out a 2m from the first term, I'm left with just m. And factoring out a 2m from the second term, I'm left with a positive 5. Now looking at the right, there is a negative 1 to begin with. But remember that we always need our first number to be positive. So I'm going to factor out a negative, and the only thing in common between 1 and 5 is a 1. So I'm factoring out a negative 1. That makes my negative 1m a positive m, and my negative 5 a positive 5. Now I see another greatest common factor of the entire polynomial, and that would be my m plus 5. I'm going to factor out that m plus 5, and that will leave me with the coefficients of 2m minus 1 in my second set of parentheses. I'll fill in my factors down below with these two binomials, m plus 5 and 2m minus 1. So your factored form is this polynomial at the bottom. Last, we're going to go into difference of squares. As in the last two examples, our first step is always to find a greatest common factor if there is one. Looking at 50x squared and negative 18, I see a common factor of positive 2. So I will factor out that positive 2, leaving me with 25x squared minus 9. I will be breaking this 25x squared minus 9 down into factored form of two sets of parentheses. So I'm going to go ahead and set these up now. And this 2, again, will just hang out on the front. That way I don't forget about it or get confused by it as I'm going through the process of factoring. Factoring that binomial inside, I see that 25 is a perfect square, as is x squared. So I can rewrite this as 5x all to the second power. I see that 9 is also a perfect square. I can rewrite that as 3 to the second power. I am taking their difference, so what I have here is the difference of two squares. One rule that we have for factoring the difference of two squares is that all we are going to do is find their bases. Here I have 5x and 3. We are going to add those bases for our first factor and subtract them for our second factor. That final polynomial is the factored form of your original. Go ahead and take a moment to pause the video and try these next 6 on your own. In just a few seconds, I will come back and walk you through the first 3. For the first, you should have identified a greatest common factor of 3 Factoring that out, you should have 2n to the third plus 1n squared plus 4n plus 2. I'm going to factor this remaining polynomial into 2 factors, so I'm going to go ahead and set that up down below, bringing my 3 down to the front. Focusing on this polynomial inside parentheses, I am going to first factor by grouping by splitting the polynomial into 2 parts. Looking at the left part of this polynomial, I see a greatest common factor of n squared. When I factor that out, I'm left with 2n plus 1. On the right, I'm going to take out a positive 2, leaving me with 2n plus 1. I see the 2n plus 1 repeated, so I will factor that out. And in my second set of parentheses, I have the coefficients of n squared and positive 2. Filling in my parentheses, my final factored form is 3 with a factor of 2n plus 1 and another of n squared plus 2. In the middle, I see a greatest common factor of 2. Factoring that out, I'm left with 2p squared minus 5p minus 12. I'm going to factor this remaining trinomial inside. Since it's a trinomial, I know I'm going to have to use the diamond method to split it into 4 terms. After doing so, I will end up with 2 factors, so I will set up my answer down below, bringing that 2 down to the front. For this trinomial, I'm going to factor by multiplying the leading coefficient of 2 by the constant term of negative 12. So multiplying those two together, I get a negative 24, and that goes on top of my x. On the bottom, I have a negative 5. I need 2 numbers that multiply to negative 24 and add to negative 5. Being strategic, I know that I'm going to need 1 positive and 1 negative number. And since I'm adding to a negative, I know that the negative has to be bigger. So I'll start with positive 1 and negative 24. That does not add to negative 5. Positive 2 and negative 12. That does not add to negative 5. Positive 3 and negative 8. That does. So I'm going to choose those as my 2 terms. With those 2 terms, I will rewrite my negative 5. I have a positive 3p and a negative 8p. The 2p squared remains on the front, and my minus 12 remains on the end. Now I can factor by grouping. Looking at this polynomial as 2 pieces, I see a common factor of p on the left, leaving me with 2p plus 3. And on the right, I need to take out a negative in order to make this 8 positive. And they have a 4 in common. So factoring out a negative 4 leaves me with positive 2p and a positive 3. Factoring out my 2p plus 3, I'm left with p minus 4 in the second parentheses. So your final factored form consists of 2 with a factor of 2p plus 3 and another of p minus 4. Last, between these 2 terms, I see a greatest common factor of 2, leaving me with 16x squared minus 25 in parentheses. Now, since this polynomial is the difference of squares, I am going to factor it and we'll end up with, again, 2 factors. That 2 I will bring down and it will remain on the front. 16x squared I will rewrite as 4x all squared, and 25 I will rewrite as 5 squared. Since I am subtracting, this is the difference of squares, so I take my bases, 4x and 5, and simply add them and subtract them. Now I'll go ahead and show you your answers to the bottom 3. For the first, you should have factored by grouping after factoring out that greatest common factor of 3, and your final factored form should have been 3 on the outside with 2 factors of r minus 2 and 3r squared minus 1. In the middle, you should have factored by the diamond method after factoring out a greatest common factor of 2, and your final factored form should have been as shown below. And to the right, you should have factored out of 2 as your greatest common factor, and then factored as the difference of squares. Thank you for reviewing with me today. I hope you enjoy the rest of your day.